Hey guys, so here's the Unit 2 Solving Equations and Inequalities test review answer key. So question number 1 says solve for x, 7x minus 3 plus 4x equals 3x plus 9 plus 2x. Our first step is usually to distribute, but we don't see any parentheses, so we're going to move on to the next step, which is combine like terms. So 7 and 4, 11x minus 3. On the other side, we have a 3x and a positive 2x. Which becomes a 5x plus 9. The next thing that we want to do is isolate our variable. So we're going to move our variable to one side and our constants to the other. So I'm going to subtract 5x and bring it to the 11. So we have 6x minus 3 equals 9. Now we're going to take that 3, add it to the other side. And 6x equals 12, divide by 6, and x is equal to 2. Solve for x, 3x minus, parentheses, x plus 1 equals 6x plus 1. So from here, first thing that we want to do is distribute that negative 1. So imagine there's a negative 1 there. So 3x I'm going to bring down. Negative 1 times x minus x. Negative 1 times a positive 1 is a negative 1. And then we're just going to bring down our 6x plus 1. From here, we want to combine like terms. So we have a 2x minus 1 equals 6x plus 1. We're going to bring our variables to one side. So now we're left with negative 1 equals 4x plus 1. Now we need to bring this one over to the negative 1 so that our constants are on one side. And then from here, we're just going to divide out by 4. And x is equal to negative 1 over 2. Remember, if you want to check your answers, just take this x that you got and substitute it into the original equation. And then the left side should equal the right-hand side. And then for 3, solve for x. X minus 3, negative 3 times 1 minus x equals 47 minus x. So we're going to start by distributing that negative 3 to both terms on the inside. After we distribute, we want to combine like terms. We're going to move our variables to one side. So we have 5x minus 3 equals 47. From here, move our constants to the other. 5x equals 50, and then we're dividing by 5 to isolate that variable, and x is equal to 10. For 4, we have something very similar. Instead of an equation, we're solving an inequality. We're going to treat it the same way. Take the negative 2 and multiply out to everything on the inside. So you have negative 2x plus 10 is greater than or equal to 50. From here, we want to isolate our variable, so we're going to take that positive 10 and subtract it over. And then you have negative 2x is greater than or equal to 40. Then from here, we're going to divide by negative 2. So x, negative 20. The reason why I left that space is so that I could remind you guys to flip that sign. Remember, when we're dividing by a negative, we have to flip the inequality symbol. For 5, determine the smallest integer that satisfies the inequality. 3 times 3x plus 2 is greater than or equal to 64. So we're going to start off by distributing. So we have 9x plus 6 is greater than or equal to 64. Then we're going to subtract 6 over to the other side. Then we're left with 9x is greater than or equal to 58. And then from here, we want to divide by 9. X is greater than or equal to 6.444. Repeating. So the question is saying, determine the smallest integer that satisfies the equation. So which number, or integer in this case, which integer could I replace that x with to make this statement true? And the answer is 7. That is the smallest integer. For here it's saying which integer or integers in the set where x is between 4 and 10 makes the following statement true. So first I'm going to solve this before I look at my domain of numbers. So I'm going to start by subtracting 2x over. I have 7x minus 3 is greater than 46. From here, I'm going to add 3 over. 7x is greater than 49. When I divide by 7, I have x is greater than 7. So let's look at our domain. So we want to know between 4, 5, 6, 7, 8, 9, and 10 because those are the numbers between 4 and 10. Just let's look at this symbol right here. There is no line underneath, so 4 actually isn't included. But here, the 10, the inequality symbol with the 10 does have a line, so that means 10 can be included. So let's go through our other choices. Can I replace that x with a 5 to make it true? No, 5 is not greater than 7. 6 won't work. I can't put a 7 there because this is saying 7 is greater than 7. That's not true. It's equal to, so 7 won't work. The 3 integers that work are 8, 9, and 10. For 7, solve the following inequality. So 3 minus 2x is less than negative 9, or negative 3x is greater than or equal to 21. So let's solve the first one on the left. So I'm going to subtract 3 over. Negative 2x is less than negative 12. Divide by negative 2. And x is greater than 6. Remember, we have to switch the signs because I'm dividing by a negative. Or we have divide by negative 3, divide by negative 3. That cancels. X, again, switch the signs, is less than or equal to negative 7. For the graphing part, remember we just need to include 6 and a negative 7 on your number line, which I have. So I'm going to start with this one over here. X is greater than 6. So at 6, I'm going to place an open circle because there is no line underneath the inequality symbol, meaning 6 is not included, and our x values are greater, which means we're shading to the right. Now let's look at this one. At negative 7, we're going to put a closed circle because there is a line underneath the inequality symbol. And then we know negative 7 is the largest number, which means our numbers in that solution have to be smaller, which means we're shading to the left. Remember, when we see or, we're thinking outwards. So we're shading both sides outwards. For this problem, we want to solve for b. So we have a is equal to b times r squared. So in order to get rid of multiplication, we have to do the inverse operation, which is division. So we're trying to isolate it, so b is by itself. So we're just going to divide both sides by r squared. That cancels out, so b is equal to a divided by r squared. And that is your final answer for that one. For the second one, we're going to start by adding 5 to the other side. So we have v plus 5 equals 4/3 pi r squared. Remember, you guys like the proportional way better, so I'm just going to extend this to make a proportion and throw that over 1. Now I could cross multiply. So we have 3 times v plus 5 equals 4 pi r squared. Again, we want to get rid of everything associated with that r. So that means we have to divide both sides by 4 pi. since it was being multiplied. So that cancels out, and now we have r squared is equal to 3 times v plus 5 over 4 times pi. To undo an exponent of 2, we need to take the square root. So our final answer is r is equal to the square root of 3 times v plus 5 all over 4 times pi. For 9, we want to set up an equation, but do not solve. So now we're just going to do the setup. And the setup consists of the sum of 3 consecutive even integers is negative 24. So when I see the sum, I'm thinking adding, but when I see even, I have to write my let statements. So the first consecutive even integer is going to be x. My second consecutive even integer is x plus 2. And my third consecutive even integer is x plus 4. Remember in class, I told you guys to pick 3 random even integers just to check. So 2, 4, 6. Again, we don't know if our first one is 2, so I'm going to call it x. How do I go from 2 to 4? I had to add 2 to the x. How do I go from 2 to 6? I had to add 4 to x. So this rule right here works for both even and odd integers. So once you have your legend, now we're going to represent the sum of the 3 consecutive even integers equaling negative 24. So my first consecutive integer is x, and I'm adding it to my second integer and adding my, adding my third. And I know all together it's going to equal negative 24. So again, if we were to solve it, we're just going to combine like terms and subtract over our constants and divide by 3. But again, we're just setting up the equation for this problem. The next one, we have a proportion. And whenever we see a proportion, we want to cross multiply. So I already have that highlighted. We're doing x times x minus 9 is equal to x plus 3 times x minus 8. So on the left-hand side, we distribute out. We have x squared minus 9x is equal to x times x, which is x squared, x times negative 8, 3 times x, and then 3 times negative 8. So I'm just going to bring down my x squared minus 9x and combine like terms on the right. So I have x squared, a negative 8, and a positive 3 is negative 5x minus 24. From here, we should see that we have x squareds on both sides, so they actually cancel out. We have negative 9x equals negative 5x minus 24. I'm going to add 5x to the other side. Negative 4x equals negative 24. From here, we want to divide by negative 4. And x is equal to positive 6. For 11, given 2x plus ax minus 7 is greater than negative 12, determine the largest integer value for a if x is equal to negative 1. So every time I see an x, I'm going to replace it with a negative 1. From here, what I want to do is do 2 times negative 1 times a times negative 1, which is a negative a, or negative 1a minus 7 is greater than negative 12. From here, combine like terms on the left. Negative 2 and negative 7 is negative 9 minus a is greater than negative 12. Add 9 to both sides. Negative a is greater than negative 3. Divide by negative 1. Again, when I divide by a negative, I have to flip my sign. So negative 3 divided by negative 1 is a positive 3.